RE model circuits, the common base circuit. So this is your common base amplifier. Your input is at the emitter and your collector where your output is connected. Then your base is common between your input and your output. So we have to change this one into your EC model circuit. So we have your IC, that is from your transistor going out to your BO. Then we have your voltage at the emitter, where we can get your impedance at the emitter, voltage I for your impedance I, and impedance IN. Then we have your output impedance. So first, we have to solve for your input impedance. We can get your input impedance by using the equation of your BE, which is equivalent to RE times IE. So that is the current flowing into your RE, then plus RB times IB. And then we have to express IB in terms of IE because our input current is your IE. So IB is equivalent to 1 minus alpha IE. So therefore, we have this equation of your BE. And if we have to divide your BE with IE, then that will be your impedance at the emitter. Getting your impedance I, that is equivalent to your RE in parallel with your impedance at the emitter. And adding RS to your impedance I, that will be your impedance IN. For output impedance, we have to set your BS to 0, so therefore we have RC in parallel with RL. For the voltage gain, so we have BO over BS. Our B input is equivalent to our BE, which is equivalent to RE times IE plus RB times 1 minus alpha IE. And our BO, that is equals to the voltage drop across RL times IO, where your BO has a negative sign because of your IO against the polarity of your BO. Then we have to get the equation of your IO. So we have RC all over RC plus RL, then times negative IC, where IC is equivalent to alpha IE. So therefore, your BO is now equivalent to a positive RL in parallel with RC alpha IE. So if we have to get the ratio between BO or BI, we call that one as your voltage gain. That is alpha RL in parallel with RC all over RE plus RB 1 minus alpha. Since our voltage input is BS, so we have to get the ratio of your BI over BS. So BI over BS, that is equivalent to your impedance I over impedance I plus RS, or that is impedance I over impedance IN. So therefore, your EBS is equals to your voltage gain, which is BO over BI, times the ratio of your BI over BS, which is impedance I over impedance IN. Then for the current gain, it is IO over IS. If we have to get the equation of your IO, that is RC in over RC plus RL times negative alpha IE. And your IE is equals to RE over RE plus impedance at your emitter times IS, then substituting this one to your IO and get the ratio, then that will be your EIS. Or you can use also the voltage gain, which is EIS equivalent to negative EBS times impedance IN over RL. So we have this example. So we have to determine the input impedance, output impedance, voltage gain, current gain, as well as your BO if your BS equals to 10 millivolts. First, we have to get your RE by using your DC analysis. So in your DC analysis, at your input side, we have IE going to your emitter base junction, then to your ATK, then to the ground. So the KVL on your input side will be 12 minus 1.2 KIE minus voltage base emitter minus 80 KIB. And we have to express your IB in terms of IE. IB is 1 minus alpha IE. So therefore, we have your IE is equals to 12 minus 0.7 over 1.2k plus 80k times 1 minus 0.97 because that is our alpha. So therefore, IE is equivalent to this value. Getting your RE, we have your 26 millivolts divided by your IE. And this is your RE. From this, we have to change this into your EC equivalent model. So this is your IO, that is your IC, then IB. This is your voltage at the emitter, where we can get your impedance at the emitter, your BI, where we can get your impedance I and impedance IN. Then we have your output impedance. So for input impedance, you have to use your equation of your BE, which is RE times IE plus ATK IB. Expressing IB in terms of IE, then we have RE IE plus ATK times 1 minus 0.97. If you have to divide your BE with IE, and that will be your impedance at the emitter, which is equivalent to RE plus ATK times 1 minus 0.97, or that is equivalent to 2408.283186 ohms. Then, to solve for your input impedance I, that is, we have 1.2k in parallel with your impedance at the emitter. So therefore, impedance I equals to 800.9182412 ohms. And we have to add your 1k, which is your RS. We can now have your input impedance IN. For output impedance, setting BS to 0, so we have 4k in parallel with 2k. And for the voltage gain, that is B over Bs, where Bi is equivalent to your voltage at your emitter, where the voltage of your emitter is equivalent to your impedance at the emitter times IE. And your Bo, that is 2k in parallel with 4k alpha IE. So we have Bo equals to 3880 over 3 IE. So if we have to get the ratio Bo over Bi, then times Bi over Bs, where Bi over Bs, that is equivalent to impedance I over impedance IN. So ABS is equals to BO over BE, where BE is equivalent to BI times impedance I over impedance IN. So therefore, your ABS is 0.8212077794. For BO, that is equivalent to your EBS times BS. So we have BS equals to 10 millivolts, then we have to multiply that to your ABS, then your BO is 8.21207794 millivolts. For current gain, that is IO over IS. If we have to get the equation of your IO, that is opposite resistance, which is 4k over 4k plus 2k, then times your alpha IE negative. Then your IE is 1.2k over 1.2k plus the impedance at the emitter times IS. So this is now your EIS. And that's all for your common base circuit under RE model.